Yes.
Yes, sir.
So, in the last class, we have discussed about the BJT. Think, yeah, DC biasing of this, right? So, we talked about operating points. We talked about various biasing techniques, emitter bias, fixed bias, and then we have voltage divider biasing, which is the best one. So, the purpose of this is that the operating point should be independent of beta, actually. That is what will be our purpose. Okay. So, today we are going to talk about FET biasing and FET or MOSFET, JFET or MOSFET biasing. So we have, right. So this is FET biasing. So if we talk about FETs, so let us come to this currents. Gate current is 0. Drain and source current, they are equal. Okay. And ID, we know it is IDSS 1 minus BGS by BP whole square. Just a minute. So drain current, we know it is equal to source current. This equation is valid for JFET and depletion type MOSFET. And ID is equal to K VGS minus VT whole square. There is more detail into this, but for MOSFET, enhancement type MOSFET, this equation we are just following, right? So here it is more related with pinch off. Okay, this one, and here it is more related with threshold voltage. Now, if we talk about fixed bias configuration, so in the fixed bias, if you see what we have is if you see this is the fixed bias configuration. Here what we have is this one. We are using two power supplies. One is this, and another one is this. This is battery number one. This is battery number two. Okay, so it is something like this. Now this is this negative is going. RD is this drain voltage. So instead of VCC here it is VDD now. Okay, we have capacitors as usual, and when we talk about DC C1 and C2, they are becoming open circuit. Okay, and if we talk about this, so let us talk about this now. So we have this capacitor here which is open circuit, this capacitor here which is open circuit, and we have this RG here. Okay, so this is becoming open circuit. I will remove this. This is also becoming open circuit. So where does this RG goes actually? Why it is not here in the DC and LC circuit? The reason being this one, because gate current here is 0. So this IG RG is equal to 0. So that means it is a short circuit. Means if voltage is 0, that is a short circuit. So there is no need of this one, as IG is 0. So the circuit is modified like this. Now it is quite simple. If I take this loop, I'll start from here, plus to minus, minus VGG. This is plus to minus, minus of VGS. Okay, so VGS is nothing but equal to minus of VGG. So this gate to drain to source voltage is this. Minus of this negative sign is here. So VGG is a fixed DC supply, we know, and voltage VGS is fixed in magnitude. Right? That's why its name is fixed bias configuration. And this is the current we know across it, because this is JFET. So ID is equal to IDSS 1 minus VGS by BP whole square. And this is how the current is going to flow. ID is there, IG is there, and IS is there. Right? This IC is 0. Okay, but this ID is equal to IS. ID is equal to IS, right? So RG permits this, like, okay. So this is Shockley's equation, we know, and if VGS is equal to PP by 2, okay, so this is becoming almost, if you see here, so drain current is IDSS by 4. This is ID is equal to IDSS 1 minus VGS by BP whole square. If VGS is equal to BP by 2, so that means it is 1 minus, so this is nothing but 1 minus 1 by 2 square, that is IDSS by 4. That's why you can see so. Anyway, so this is what we are getting, and if we have to find out the another loop, if we see this is RT और current निकालने के लिए, this is for, because current meter, if we have to find out the current here ID, we have to place the ammeter in series. Okay, that's why this ammeter is here, and this ID current is flowing from here. Okay, so if I'll take this loop from here to here, this is nothing but this is something like this. This is VDD. Okay, battery is like this. So I'll start from this. I'll start from ground. I'll end up ground. So what I find is plus VDS plus IDRD minus VDD, that is equal to 0. Or if I'll start from here, minus to plus, plus VDD plus to minus, current flows from higher potential to lower potential. This is plus, this is minus. So minus of IDRD, and drop across this is VDS. So minus VDS is equal to 0. This relation. Okay. So VDS is nothing but VDD minus IDRD. It is same if you remember, VC is equal to VCC minus IC RC. सेम वैसी चीज है. This is VCC, this is IC RC. So VCE is nothing but VCC minus ICRC. That's it. Okay. So this is about the fixed biasing technique. So that is about this. If I'll take this example, I'll take this example. Here, if you see, we have to find out this VGS. So this VGS is nothing. IG across it is 0. Okay, it is equal to minus of 2 volts. That's all. So there is no drop across this 0 volt. Drop across 1 ohm. And if I have to find out this ID, okay, so this is the formula. This is given, so you can find out. Because I have given this and this, so directly from Shockley's equation you can find out. Right? VDS you can find out, VDD minus IDRD, quite simple. Okay, VD is, what is VD? What is this voltage? This is, this VD is equal to VDS because this source is at ground. So that is equal to this. So whatever is the VDS, that is equal to VD also. And what is VG? VG is nothing but equal to VGS because source is at ground. Am I right? Okay. So VGS we have find out. This is also equal to VG. And what is V source? V source is 0. Right? Anji, are you able to understand this?
Yes, sir.
Okay.
नव्वड़ जोक्स सही में नीचे है ये है उधर
Can you see this? Anna? So VD is equal to VDS, VG is equal to VGS. Okay. Now we have one another voltage divider biasing. Okay. Let me check. Okay. This is JFET self-biasing. So once you understand how the currents they are flowing, it is very easy. This is ID current or DC analysis. What is going to happen? This is going to be open circuit. This is also going to be open. Okay. This current we know This is IC current. We know that is equal to 0. Okay. So IC is 0 if you see. So what we left is, we are left with this now. So if this is 0, you can see this IC current is 0. So IGRG should be how much? 0. And if I take this loop, so that this 0 means this is short circuit. If voltage is 0, that is short circuiting. If current is 0, that is called as open circuit. Okay. So now this is like this. So this is short circuit. Fine. So what we left is, we are left with this only. So if I take this loop, this is quite simple. Here current is flowing IS. Okay. IS we know it is equal to ID. So इसको ID लिख लो या IS लिख लो, एक ही बात है. So this is IDRS, and this VRS is nothing but equal to this voltage drop is IDRS, or this VGS is equal to minus of IDRS. That's it from this equation. And this VDS is, you can take this loop. Okay, what it should be, ये है VDD, minus to plus, plus VDD. If I talk about this, it is plus VDD minus IDRD minus VDS minus ISR. Sorry. This is IDRS, that is equal to 0. So VDS is nothing but VDD minus IDRD or minus ID, like this. So that is how it is going to be modified. Okay. So this is how we are finding out this ID and this VDS. This is just we are trying to find out when we talk about this. So if you go for this again, this is what we are getting. VDD minus ID, R plus RD. So VG we know it is 0 because we don't have any gate current. And VS is equal to IDRS. So we can find out all these parameters here. Okay. Next is this is voltage divider biasing here also. If you see, this is voltage divider biasing. And again, when we do the DC analysis, this is going to be open circuit. This is also going to be open circuit. Okay. This gate current is 0. Right? तो ये भी open circuit ही एक तरह से. So this is nothing but a voltage divider. Whatever voltage we are having, this is modified like this. This is R1, this is R2, this is VDD. So this is VThevenin, and this we can find out. So R Thevenin is R parallel R1 parallel R2, and VThevenin is VDD R2 into R1 plus R2. Okay. So here, if you remember, in case of VZT, we try to make IB equal to 0. So we have that beta plus 1 RE should be equal to 10 of RE like this. Something like this. We have to improvise. 10 of RC. Something like this we have to use. But here, because gate current is already 0, approximately 0, so no need for those modifications here. But we have to, or we are saying these capacitors, they are open circuit. Now if I go for this, so like this, so this VZ, that is VThevenin type thing, and because this is R1 parallel R2, VZ is R2 divided by this, and this is what we are getting here. So here, if you see in this circuit, अगर आप ये देखिए, this voltage is VDD R2 divided by R1 plus R2. If we know this voltage, right, and we know this voltage, we can make a loop. एक तरह से इसके क्रॉस वोल्टेज है, this point versus ground. Okay, so you can find out this loop. If you are able to know about this, you can also find out this loop. That's why it is quite simple from here. So this VZ minus VGS minus VRS. VRS is nothing but minus of IDRS. This is also ID. So you can find out any voltage from here. And this also, this one, this is nothing but VDD minus IDRD minus IDRS. So this is something what you are getting. Okay. So this is about voltage divider biasing. VGS we know. This voltage, if we talk about VGS, this is equal to VG minus VRS और VG minus IDRS, कुछ भी दोनों लिख सकते हैं. So these are relations for finding out. Can you find out these things? ये करना आ रहा है आपको वैसे? Hello. Tell me one thing. Are you able to solve these equations? Kirchhoff's voltage law and current law. Hello. How many of you are able to understand this? Say yes or no.
No, sir.
No? Hello.
No.
क्या समझ नहीं आ रहा है इसमें? बताओ. Whenever we are going to solve these type of questions, one is we are going to take this loop. The first loop which we have to take is this loop. Okay?
Yes,
Another
sir.
one, this loop. Okay? Same is we are doing for the BJT and GFET के लिए. Right? Second part is you have to go for what? This one. Currents. Always. This is what you have to write down the currents. This current, you know, this current is nothing but it is equal to ID. This gate current is 0. Clear? So currents you have to name. Then voltages. This is BGS. This is nothing but this is BDS. Okay. Or this BDD is given. This voltage we have find out, because if there is no current towards this side, that means it is open circuit. So it is something like this. So can you find out this voltage? The voltage divider है ना, ये ऐसे है बेटा, एक तरह से अगर आप देखो तो क्या है ये, this is R1, this is R2, this is VDD. तो ये वोल्टेज कितनी हुई, मान लो ये 10 है, ये 1 किलो ओम है, ये भी 1 किलो ओम है, so this is 10 into 1k divided by 1 plus 1k, so this is 5 volts. तो वही यहाँ की है, this R2 divided by R1 plus R2, और इसके क्रॉस कितना ड्रॉप है, VDD R1 divided by R1 plus R2, that's it. ओके मतलब ये 10 है, अगर यहाँ 3 वोल्ट ड्रॉप है तो 7 वोल्ट यहाँ होगा. Am I right?
Yes, sir.
तो दिस इज द अनदर वे. तीसरा क्या है, इस लूप को लेना है, अब लूप बनाना आना चाहिए. दिस इज IZ, करंट फ्लोज फ्रॉम हायर पोटेंशियल टू लोअर. ओके, सो दिस शुड बी minus IGR2, but value of IZ is 0 in the circuitry, so this is nowhere in the equations actually. So we'll start from here to, इसके क्रॉस वोल्टेज 0 है, माइनस VG और प्लस BG कर सकते हैं इसको, माइनस टू प्लस. If you go from this to this, minus to plus, here to here, plus BG, this is VGS is from plus to minus, minus VGS, and this is IDRS, so minus IDRD. RS is equal to 0. From here you can find out the VGS, that is VG minus IDRS. That's it. और कुछ नहीं है equations में. Same is true for here. अब इसमें क्या है, जब भी ऐसा करना हो तो इसको बैटरी बना लो, बैटरी की तरह देखना स्टार्ट कर. दिस इज पॉजिटिव साइड, दिस इज नेगेटिव. बैटरी ऐसे लगाएंगे ना अगर होगी तो. सो आई विल स्टार्ट फ्रॉम दिस पॉइंट, पॉइंट 1 to पॉइंट 2, तब लूप कंप्लीट हो जाएगा. ओके अगर ऐसे चलूंगा तो 0 से स्टार्ट किया और 0 पे एंड हो गया. So I'll start from here. This is the first point, minus to plus, plus VDD. Across this, it is IDRD. So current flows from higher potential to lower potential. Then we have, this is VDS. So this is positive side, this is negative, so minus VDS. This is ID into RS. Current flows from higher potential to lower. That is equal to 0. So VDS is nothing but VD minus IDRD minus IDRS. Or in the nutshell, you can say RD plus RS. That's it. I hope you understand it now. Hello.
Yes, sir.
Okay. Any questions regarding this now? So first part is current लिखो, IC, IB, IE. In case of BJT, इसमें क्या है? ID, IG. तो IG यहाँ आसान है कि IG यहाँ 0 है, whether it is MOSFET or JFET, दोनों में से कोई भी, है ना? ओके, चलो जरा एक क्वेश्चन करो, फिर करो जरा इस क्वेश्चन को. Okay, so first part is, this is ID, this is IG is equal to 0, this is ID again, and we know ID is equal to IDSS 1 minus BGS by BP whole square, so that you can find out from here. It means we should know BGS first, so BGS is to be find out from this loop. करो जरा इसको, solve this question. Are you able to solve it? Hello. Just write down yes or no. How many of you are able to start solving it? Right? Yes or no? Okay, so just solve this question, right? And we'll discuss the MOSFET based biasing in the next class, right? So, but you should start solving these numericals based upon VGT and this. So first you start with the solved problems. Only then you can do the unsolved problems. Okay. So thanks for being with me, and see you tomorrow.
Okay, sir. Thank you.
Okay. Bye.
Thank you, sir.
Thank you, sir.
Thank you. Thank you all.